All right, today we're going to look at angle measures that are formed by chords and secants and tangents inside the circle. Mostly chords and secants because they will pass through the circle. All right, a chord is a segment that has endpoints on your circle. So these guys are chords, okay? So as we can see, these chords are not diameters, okay? And there's no indication to say that they're diameters. And we want to know the measure of this angle x from here to here, which would be the same as this angle on the side here because they are vertical angles. What we do is, very much like inscribed angles, we're going to trace the angle and we're going to look at its intercepted arc, and that's 116 degrees. However, this is also angle x on this side because they are vertical angles, and this angle also has an intercepted arc of 70 degrees. So the measures of the angles that are formed by two lines that intersect inside a circle is half the sum of the two intercepted arcs. So we add up 116 and 70, we get 186, and we take half of that measure, and it would be 93. So x is equal to 93 degrees. So let's see how this would work with either a missing angle or a missing arc. Okay, so here we have two chords intersecting inside the circle. Again, there's no indication to tell us that they're diameters. All right. And we see that this angle here is 139 degrees, which is also equal to this angle. The problem is the arcs in question are here at 40 and here at x, and we want to find the measure of one of the arcs. So basically what we have to do is take 180 degrees and minus the 139 degrees so that we can get this angle here and here, which are also equal, okay, because they're vertical angles. So when we do that, we're going to get 41 degrees. All right, so these guys are 41 degrees. So I'm just going to put the 1 here just so we can see it. These angles have an intercepted arc of 40 and an intercepted arc of x, okay? And what we know is that the measure of the angle equals to the sum of the intercepted arcs, so 40 plus x over 2, okay? So we're going to replace our angle with 41 degrees because that's what we found it to be by the last step. So it's going to be the average of the intercepted arcs. So we're going to cross multiply, and we're going to get that this is 82 equals 40 plus x. We subtract 40 on each side, and x is going to equal 42. So the measure of our arc, x, is 42 degrees. All right, and that's how you find that. Okay, here we have another problem. We'll move that up so it's a little easier to see. And we want to find the measure of this angle x here, which will also equal this one. All right, but the intercepted arcs that we have are here. So we need these angles and information to help us. So what we'll do is we'll make this angle y. All right, just give it another variable name because we have these angles, which are equal, and they're intercepted arcs right here of 28 and 20. All right, so the measure of angle y, which we don't know, is going to be the average of the two intercepted arcs, or the sum of the two arcs divided by 2. So this is going to be 48 over 2. So the measure of angle y is going to equal to 24 degrees. So we'll put 24 in here. That's our angle measure. Okay. Well, now you can just resort to what you know about linear pair of angles form 180 degrees. So x plus the 24 equals 180 degrees. So you subtract the 24. Okay, and x is going to equal 7, 6, and 5, and 1, so 156. Okay, so x is 156 degrees. And that would be here. Okay, now we can also have angles that are formed externally outside our circles, and they're formed by secants or tangents and other secants. It's a combination of the two. So let's take a look at what that is. So here's our angle right here. It's X. Okay, that's our angle from here to here. And what we have is an intercepted arc here that this would, if this angle in its entirety were to swallow up or chomp down or Pac-Man style, eat the arc, it would eat this one and this one. So these are the two intercepted arcs in this case, okay, for that angle. When your angle is exterior to the circle formed by chords or tangents, or secants or tangents, or a combination of secants and tangents, then your angle measure is going to be half of the difference of the two intercepted arcs. These arcs out here have no play in this problem. So it's going to be 90 minus 20, which is 70. And you're going to take half that amount, which is 35, and that's going to equal to your measure of angle X. All right, next up, we have an exterior angle X that is formed by two tangents. Okay, so really the intercepted arcs are from this point of tangent C to this point of tangent C, both here on the outside, which is 240 degrees, and also here closest to the angle on this side, which would be the difference of 360 and 240. So that's the first thing you want to do, is take 360 minus 240 so that you can find out what the measure of this arc is, and it's 120. So I'm going to put 120 degrees right here on that arc. All right, so now what we're going to do is we want the exterior angle X. So the measure of angle X is going to equal to the difference of the two intercepted arcs, which is 240 minus 120, all over 2. Okay, so we're going to get the measure of angle X is equal to 120 over 2. So the measure of angle X is equal to 60 degrees. And that's what this angle is here, 60 degrees. All right, move that up for a little ease. All right, so now we have an angle exterior to the circle that is formed by a tangent and a secant. Okay, again, you're looking at what this angle can literally swallow up as far as its arcs. So here's our angle, and this is one of the arcs, and this is the other arc that it would be able to swallow up. All right, so what we have is this arc here is 120. We need that information. This is 60. This one is the unknown, so we need that. So we're going to take 120 and 60, oh, sorry, it was 65. And 65, I'm going to get 185 degrees, right? So we're going to take 360 and subtract 185. And we're going to get 175 degrees, okay? All right? So that's what this is. Now it's 175 degrees. And I would write it on here so you can see it. All right, so now we need measure of angle X, and the measure of angle X is always going to be the difference of the two arcs, and it's always high minus low. You're not going to have negative angles, so it's always high minus low. So the measure of angle X is going to equal to 175 minus 65 divided by 2. So the measure of angle X is going to be 110 over 2, which is going to be 55 degrees. So this angle in here is 55 degrees. All right. All right, a couple more complex looking problems just so you can see how this works, okay, because they can get kind of jazzy. All right, so what we have is an exterior angle out here, X, that's this guy. We have an arc here, which is 24, and we have an arc here, which is 96. We don't have this measure or that measure, and we'll have to see if we're going to need it. Okay. All right, and let's see what we've got. All right, so ready? Okay, so I think the easiest one to find from my perspective looking at it right now would be angle Z. The measure of angle Z is going to be half of its intercepted arc. So here's angle Z, and this is its intercepted arc. This is an interior angle. It's an inscribed angle, actually. On the inside of our circle, the vertex is right on the circle. So the measure of angle Z, pretty quickly enough, is 96 divided by 2. So the measure of angle Z is going to be, divided by 2, that's going to be 48. So 48 degrees. I'm going to put that in here so I can see it. Okay. Okay. Next up. All right. We're going to look for, I think angle Y would be pretty easy to find at this point. Okay, so angle Y is formed here by this angle, and its intercepted arc is again 96 degrees. But remember, angle Y equals to this one here because they are vertical angles. So that's 24 degrees for its intercepted arc. So the measure of angle Y is going to be the sum of 96 plus 24 divided by 2. Okay, so that comes out to be, the measure of angle Y is 120. 96 and 24, 120, and that's going to give us, divided by 2, so the measure of angle Y is going to give us 60 degrees. So I'm going to put 60 here so we can see it. Okay, and now we need X, and X is the exterior angle. Okay, and it's formed by this secant and this secant. So its arcs are 24 and 96. So the measure of angle X is equal to the difference of 96 minus 24 divided by 2. The measure of angle X is equal to 96 minus 24 is going to give us 72 over 2, which equals 36 degrees. So that's the measure of angle X, which is 36 degrees. So again, you could have tackled these in a different order, but it depends on how you see it in the given moment. All right, next problem set. Okay, if we want to find angle X, Y, and Z. All right. It's kind of cool on how you can do this one. All right, first of all, we have this arc from here to here is 232. We need this one on the inside here. So 360 minus 232 is going to be 128. So this arc here is 128 degrees. All right, so I think I'd go for Z at this point. So a measure of angle Z is going to equal to 232 minus 128 all over 2. Okay, it's an exterior angle. It's going to equal the difference of the two intercepted arcs divided by 2. Okay, and that's going to equal 104 divided by 2, which is going to give us 52 degrees. So that's the measure of angle Z. So this guy is 52 degrees. Now you have a couple of ways you can go about doing angle X and Y. One is that this is a triangle. This is not a diameter, nor is there any indication that it is. These are tangent lines, which means they are equal. So you could then take 180 minus 52 and split the difference between X and Y. All right, because it's an isosceles triangle, which means those angles X and Y are equal. Or you could use your idea of intercepting arcs here and angles. So a secant or chord and a tangent with the vertex on the circle act just like an inscribed angle, which means that the measure of angle Y, which happens to equal the measure of angle Z, okay, same thing, and that's its intercepted arc, is going to equal to 128 divided by 2, which is going to give you 64 degrees. All right, so that's what these guys are, 64 and 64. All right. And last problem, a little more complex looking. All right. This is a diameter, and I know that right away because this is 180 degrees, which means the rest of this is 180. All right, so in order to get x, I need to know this piece, okay? So to know that piece, I need to know this, and I can get that quickly. Here's an inscribed angle. Vertex is on the circle, and its intercepted arc is here. Inscribed angles are half of its intercepted arc, so this arc, we can call it AB just for a name. So the measure of arc AB is going to be 2 times 46. So the measure of arc AB is going to be 92. Okay. So, okay. All right, so this is going to be 92 degrees. And I'm going to put that out here. All right. So then the balance of 180 minus 92 to give us, let's name that C, of arc AC will be whatever this is. So we're going to do 10, that's going to be 8, and that's going to be 8, so 88. So this arc is 88 degrees, and that would be then the measure of arc AC. So we've got all our information, okay? And now what we want to do is find the measure of angle X and Z. Since we got this information, let's just go for X right away, because that's why we really needed it. X is this angle, exterior, formed by 2 lines, being a tangent and a secant. Intercepted arc, intercepted arc. So it's going to be 180 minus 88 divided by 2. So the measure of angle X is going to be 92 divided by 2, which was 46 degrees. So the measure of angle X right here is 46 degrees. All right, now we do need angle Z, which is not so bad. Okay, angle Z's angle is here, and its intercepted arc is 88. So the measure of angle Z equals 88 divided by 2, because it's an inscribed angle, which means it's half its intercepted arc, so 44 degrees. And there you go. All right, now we need to look for angle Y. Angle Y is actually pretty easy. Angle Y is here, and swallows up this intercepted arc of 180. Again, angle Y is an inscribed angle. It's half of its intercepted arc of 180, which equals 90 degrees. So this is a right angle. And then you can double check yourself. 44 and 46 is 90, plus another 90 is 180, so you know your triangle is 180 degrees. Okay, you can check that out. All right, and I think that's it. And that's how you work with inscribed angles and angles that are formed exterior to the circle by tangents and secants and chords and any combination thereof.